when it comes to these graphing problems, just kind of follow each step. Don't try and jump right to the end. Part A says find the y-intercept. So remember, how do you find the y-intercept? You let x be 0. So I'm going to take 0 and plug it in here everywhere I see x. That'll be 0 squared minus 4. So numerator is 4, denominator is negative 4. That means my y-intercept is going to be negative 1. For the next part, for what values of x is g of x undefined? That always happens when the denominator is equal to 0. So we have this x squared minus 4 is equal to 0. We can go ahead and solve that. X squared is equal to 4. When we take the square root, x is equal to plus or minus 2. This is going to be our answer for the asymptotes. When it comes to the vertical asymptote, I have two x values for which the function is undefined. That means I have two vertical asymptotes. The first one being x equals 2. The next one being x equals negative 2. When it comes to the horizontal asymptote, that has everything to do with the degrees of the numerator and the denominator. Because the numerator has a degree of 0, because there's no x's in it, and the denominator has a degree of 2 because it's x squared, that means the degree of the numerator is smaller than the degree of the denominator, and y will then equal 0. Next, you'll notice that I have you evaluate for two different points. For g of negative 3, all we have to do is take negative 3 and plug it into our function everywhere we see x. So when we have x squared minus 4 in the denominator, I'm going to substitute negative 3. Well, negative 3 squared is 9, and 9 minus 4 is 5. So this will simplify to being 4/5, or 0.8. When it comes to g of 3, instead of substituting negative 3, now we'll substitute positive 3. But that won't really matter because 3 squared is 9 again. And 9 minus 4 is still 5. So we have 4/5 again. All of this information collectively will help us with the graph. So go back through from part A through part D and let each part help you. First of all, part A says the y-intercept is at negative 1. So I'm going to plot a point right there. Skip over part B because in part C we have the vertical and horizontal asymptotes. Remember, with the vertical asymptotes we have two of them. One of them is at x equals 2. So on the x-axis, find 2 and draw a vertical line, using the dotted line to signify that it's an asymptote. Our second vertical asymptote is at x equals negative 2. So at negative 2 on the x-axis, draw a vertical line. Dotted line because it's an asymptote. The horizontal asymptote is a line y equals 0. So on the y-axis, find 0 and draw a horizontal dotted line. Now we have all of our boundaries, so to speak. I already know that because my y-intercept is at negative 1, that my curve has to go through this negative 1 and then try and get over to this asymptote on the right and this one on the left. But what about the other regions? And that's why I had you evaluate the other 2 points. Because we evaluated g at negative 3, that means that when x is negative 3, we found the y-coordinate to be 4/5. So if I plot negative 3, 4/5, that's about 0.8, just below 1. I know that my curve has to go through that point and then get closer to the asymptotes. This vertical asymptote and this horizontal one. So there's a good graph there. For g of 3, we came up with the ordered pair being an x-coordinate of 3 and a y-coordinate of, again, 4/5. So over at x equals 3, we have this point at 4/5. And again, our graph is going to go through that point and then get closer to both asymptotes, that vertical one and this horizontal one. And there's a good sketch of the graph of g of x.